All right, so today we're going to be talking about our wireless access points. Now, we have been making wireless products since the late 90s when Wi-Fi first came about. When I joined Zyxel 2 decades ago, um, we already had 802.11 PCMCIA cards that had been discontinued and were old stock. So that's 802.11, not 802.11b or G or A. It was just simply 802.11, the very first flavor of wireless. We've been doing it ever since. For a while, we had a sister company that made Wi-Fi chipsets. They patented a number of really cool technologies that are still being used today in our access points. That company ended up being sold off to Qualcomm, or what became Qualcomm, um, for those patents and for some of that technology that we had. Now, when you look at our access points, we have three different types of antennas. We have your static antenna, which is what you would traditionally get on most vendors' products. It's got a single antenna pattern built into it, usually designed with the idea that you will be mounting the access point on the ceiling and covering the area below it. We have what we call a dual optimized antenna, and we have our smart antenna technology. So we'll start by talking about the dual optimized antennas. As mentioned before, most of your access points that you're going to find out there just have a single antenna that's optimized for the idea that it's going to be mounted on the ceiling. The signal radiates out in roughly a circular pattern aimed slightly downwards to be able to cover the area below it. The problem that you run into out there is you don't always get to mount your access point on the ceiling above the area to be covered. Oftentimes we have to compromise and mount the access point on the wall. Now, the problem you run into with this is that you end up sending a lot of the signal up into the ceiling, a lot of the signal down into the floor. So that's wasted signal. You're not getting ideal coverage from it. And depending on what the floor and ceiling materials are made of, you may be causing interference to the floors above and below you. So our solution to this was our dual optimized antenna. And so instead of having one set antenna pattern built in, we have two different sets of antennas built into the access points. So you can choose whether to use a ceiling mount pattern or a pattern that's been optimized for mounting the access point on the wall. So that way you can standardize on one product and choose which antenna you want to be using based on where that individual access point has been installed. Now, to find this technology on our access points, when you look at the model numbers, if the end in the letter D or the letters D-I, that is telling you that that access point has built-in dual optimized antennas. So that's what you want to look for on the price list or on our product guides if you want to test out dual optimized antennas. The other technology we have here is smart antenna. And when it comes to smart antennas, unfortunately, this is not a trademark term. This is a generic term. So there's lots of different flavors out there of companies calling themselves smart antenna with various different capabilities. So our smart antenna is going to be similar to Ruckus's BeamFlex. So if that's something you've used before, it's basically the same general idea. And basically what happens here is the smart antenna has been designed to solve a number of different issues we run into. One is to increase coverage. In general, with the smart antenna, you're going to be able to cover a physically larger area. You're going to be able to increase capacity, have more users on the same access point, and reduce the airtime conflicts that you run into as you add more and more. And then just in general, it's going to help reduce interference, whether that interference is other access points or other devices that may be broadcasting or putting out RF radiation. So again, here is your typical antenna. You've got a static antenna pattern. It's designed to radiate downwards and outwards. And we'll show here, this is a source of interference. So in this example here, we're using a microwave oven. So that puts out 2.4 gigahertz. So that can cause interference to your 2.4 users. And when that puts out that, so when you're microwaving your lunch, it's going to cause some interference issues with those clients. So the way smart antenna works is instead of having one fixed ceiling pattern or having two like our dual optimized antennas, instead what we have here is we have the ability to choose from hundreds of different antenna patterns. And that happens essentially in real time. So we'll take a look at where the client device is that we're talking to, and we will choose an antenna pattern that focuses the signal towards that wireless client. In addition to that, our algorithm, and this is something that makes us different than most other vendors out there claiming smart antenna, also looks for other sources of RF interference. And we'll choose an antenna pattern both to optimize the signal going towards the client it's talking to, but also so it can ignore interference and not pick up those signals from those interference. And again, this works in real time, and this works with moving clients. So the clients do not need to be static. They can move around and it is going to work for you. So we've just got here a comparison here. This is comparing our WAX 650S with an HP Aruba 515. Both of these are 5 gigahertz Wi-Fi 6 access points that support 4 spatial streams on the 5 gigahertz radio. So you can see here we've got transmit performance and RX performance. And as we get further and further away from the access point, as you would expect, some speeds drop. But as you can see, we're always going to be outperforming the non-smart antenna HP Aruba product here, just about every position in our test bed. Now, obviously, people like us like to make lots of claims. So a number of years back here, the University of Brescia in Italy, their computer science group, specifically the networking group, saw claims being made by us and Ruckus about smart antenna and decided to test it. So they bought one of our access points, they bought a Ruckus Beamflex access point, they bought a Cisco, and they bought an HP Aruba, which do not have smart antenna technology, and put them through a number of tests. I believe this link is still good here. This will take you to their entire white paper where they go through everything that got put into their testing that they did, clean room environment, real world environment, et cetera. So if you want to see that, it's all there. But a quick summary here for you is what they found is when it comes to code channel interference, so that's interference from other access points or other wireless devices that are nearby, there was up to a 70% improvement between smart antenna and non-smart antenna devices. In the case of comparing us to Cisco, we had up to a 56% better performance. And then when it comes to other smart antenna vendors, in this case Ruckus, up to 45% better performance, depending on the environment and what was being tested. Specifically, we did a lot better than them when it came to co-channel interference issues. Performance was very similar in clean airtime environments. If you search for simply Zyxel smart antenna white paper, we have a white paper where we've summarized the results and put it together in a format that you can easily share with your customers to explain to them why they might consider using smart antenna for their applications. And again, if you're interested in smart antenna technology, if the access point model number ends in the letter S, that's telling you that that access point has a smart antenna built in. So now we'll talk a little bit here about some of the features you will find across most of our access points. So one of them here is basically easy to set up and use mesh. So whether you are using a local controller or a Nebula Cloud Management, both offer mesh functionality here for you. And that basically allows you to extend out and put access point in places where you don't necessarily have the ability to run Cat5 cable. In addition, our Smart Mesh and Nebula can also be used as a failover. So if for some reason somebody severs or unplugs the Ethernet cable from the switch going to one of your access points, it can automatically switch itself over into mesh mode until such time as the wired connection gets restored. We do support dynamic pre-shared key. So what this is when it comes to businesses, best practices are to use 8021X authentication to provide each user their own username and password in order to be able to get onto the network. And for whatever reasons, generally, some of the administration things, we always come across businesses, some of them bigger than you would expect, that just use a single pre-shared key for all of their employees. Now, the challenge with this, of course, is security, right? If everybody is sharing the same password, if somebody leaves your company, at any point, they can drive out to your parking lot and connect back into the corporate network and access corporate resources. So you have to then either risk that or have everybody change their password at the same time anytime somebody leaves the company. So with dynamic pre-shared key, you get the simplicity of using a pre-shared key for internet access or Wi-Fi access, but you get the security of 802.1x authentication that you would get with WPA Enterprise. And so basically the way this works is you have one SSID that all of your users connect to, but each user gets their own unique pre-shared key. So when the user connects to that SSID, it can look at the pre-shared key that was used for authentication, and then we'll assign that user to VLANs based on their login. So then you've got the ability here that each users are different classes of users. You can restrict what network resources they have access to by using the pre-shared key to link that to different VLANs. And then of course, if at any point one of your employees leaves, you simply disable their pre-shared key and they will no longer be able to connect to that network. And you don't have to worry about, like with Enterprise, WPA Enterprise, having to go into the settings on laptops and phones and put in the credentials and security certificates and stuff needed to use enterprise-based WPA. With Nebula, if you are using our Nebula Pro optional license in Nebula, it unlocks the ability to use artificial intelligence to monitor your wireless network and automatically make changes to the wireless network based on what we see as far as user connectivity to those access points. So it's a way to automatically be able to change channels, to be able to move clients to different access points, to tweak some other settings in there. Based on the historical performance of the client devices that are connecting to your network. All of our access points use what we call RF first by design, or should I say all of our business class access points. So anything that has 3 or more numbers in the model number, I would consider our business class access points. So what you will see are some differences when you compare these to our competitors. If you hold up one of our access points in one hand and hold up a Ubiquiti or Ruckus in the other hand, you will notice that ours weighs a lot more. And that has to do with how we've designed these devices. So this helps us both as far as RF performance go and also helps us with longevity on our access points. It's one of the reasons why we can offer a sub $100 access point with a lifetime warranty, where most of our competitors in that space are only offering 1 or 2. So we're dealing with solid state hardware here. So one of the major causes of failure on solid state hardware is heat fatigue. It can cause the little micro switches inside your chips to fail. It can cause solder joints to fail over time. So what we have is we have a large metal heat sink that goes behind the main PCBA to draw heat off the components of the PCBA. And then we've got a ton of vent holes in the top of our access point to allow that heat to radiate out. If you look at some of our competitors here in the lower end space, you will find that they don't have any vent holes at all, let alone a heat sink to draw heat off of the board. And then the other thing that we do is we do not use electrolytic capacitors. We only use solid state capacitors. That's another common cause of failure on solid state components. The next part here is the RF design. So you will see we generally have a lot more shielding on our PCBA boards than you would see on most of our competition. So we have the regular shielding that's on there to deal with EMI issues, so interference between the different chips on the board. But then we have additional shielding that goes on our board to help shield out neighboring 4G and 5G signals. Now, in a home or something like that, it's not going to make a difference. But if you're doing an installation in a large office building, chances are they are using what's called a DAS system, DAS, which helps distribute cellular signals inside the building so that you have a good connection even though you're indoors. And those signals can easily overwhelm Wi-Fi signals if they're placed close to your access points. So our shielding that we add into our boards helps protect that. The other difference is we do not put our antennas directly onto the PCBA. Instead, our antennas are going to be mounted on their own PCBA separate from the main board to create extra isolation between what those antennas are able to pick up and reduce the risk of interference coming off the board. And most of our access points will also have another metal shield that sits between the main board and that antenna board to provide even greater isolation between the two. Another cool feature we have on many of our higher end business class access points, usually those that start with the letter W, is the ability to turn our access point into a remotely managed VPN appliance. So this provides an alternative for you to being able to easily allow your remote workers to be able to connect back to the main office. So instead of having to use software and configure software on each of their devices they may need to connect, instead what you do is you simply provide them one of our access points. They plug it into their existing router, and because this is an access point and not a VPN appliance, you don't have to worry about it ended up being double natted behind their existing home router that they got from their ISP. This plugs in and works just like any other access point would when plugged into a router. And it broadcasts an SSID that you set up and manage, that basically any device that connects to that SSID gets put onto a VPN connection back to the main office. So basically they go home, open up their laptop, open up their tablet, connect to that SSID, and they've got access to all of their work resources wherever they happen to be. It's also easy for you if you're moving from location to location. They can just take the access point with them and plug it in wherever they go. Now, obviously, there's some security issues, right? You don't want the kids logging into that SSID. You don't want the neighbors logging into it. So in order to be able to use it, we do have to use 802.1x authentication. So they are having to connect and log in using a username and password. And you also have the ability to enable two-factor authentication to further lock down that connection. But that works with just about any of our W series access points. And we've got a number of different options here for you when it comes to providing outdoor wireless. Now, we don't really do point-to-point wireless. Our access points can support it, but generally that's not our main focus. Our main focus is providing coverage in outdoor areas, RV parks, a pool at a hotel, between the yards, things like that. So we've got a couple different options for you. On the lower end here, we have our NWA series, the NWA 55AXE. So it's an AX 1800 outdoor access point. It's IP55 rated, and it has two external antennas. Those can be replaced if you want. It uses standard RPSMA connectors. But this is going to be our entry-level product. It can provide point-to-point links if you want, or bridging between those two if you need to connect, say, your barn to your main office, etc. We have our WAC 6553D-E. This is our big workhorse that we've had for a number of years here. So it's an outdoor access point. It's AC 1750. It's IP66 rated, so a little bit heavier duty rated there for you. It has a heater built in for really cold environments. This does not come with any antennas. It has 3 antenna ports for each radio. Those are N-type connectors. So we sell some omnidirectional antennas, or you can source your own omnidirectional or directional antennas to plug into this guy here. And then on the higher end here, we have our WAX 655E. So very similar to the 6553D-E. It provides a 4x4 5 gigahertz radio and a 2x2 2.4 gigahertz radio in it. And then if you're trying to do outdoors on the cheap here, we have our outdoor enclosure, which allows you to take most of our indoor APs and mount them outside. The enclosure helps protect them from water and also provides a little bit extra thermal protection to extend the heat range that your access points can operate in. It works with most of our access points, so it's a nice, easy way. If you've already got a whole bunch of WAX 630Ss sitting in the box, you can buy one of these outdoor enclosures, pop the access point into it, and then mount this outdoors where you need your coverage. So now I want to talk a little bit about Wi-Fi 6 and Wi-Fi 6E for you here. There's still, I still consider these newer technologies, right? We're seeing 11 AC products largely being phased out. But we still run a lot of you out there that are using the 11 AC and haven't made the jump yet. So I do want to talk about some of the benefits here for you. I have a question here asking on the WAX 655E, the distance. So if you're talking about just general coverage area, there's not going to be much difference here. Generally, when you're providing Wi-Fi coverage to your users, The limitation is not the access point. The limitation is going to be the client devices themselves. One of our access points with the antennas on there can be putting out full 1 watt of power, but your phone or your tablet that you're using to connect back is probably providing somewhere in the neighborhood of 35 to 50 milliwatts of power. So those are generally going to be the limitation as far as that goes. If you're trying to provide a point-to-point link, maximum distance on these guys here is probably somewhere in the neighborhood of around half a mile. And that has to do with the fact that, unlike dedicated outdoor point-to-point products, ours are optimized for wireless clients. So if you get beyond about half a mile or so, you start running into issues with timeouts. Basically, the access point is waiting for a response from the client device or from the other side of the bridge, and it gives up too quickly. Whereas if you had a dedicated outdoor point-to-point product, those have been tweaked specifically to allow longer timeout windows to compensate for the further distances that they can cover. So while the signal may be able to go several miles, anything beyond half a mile, you're going to start running into issues with. Anyways, back onto Wi-Fi 6. So Wi-Fi 6 versus 11AC, it's up to 40% faster. It was specifically designed to solve a lot of the issues that have been plaguing Wi-Fi since back in 1999 when the first 802.11 standard came out. Basically, between 1999 and the launch of Wi-Fi 6, there was very little change made to the underlying mechanisms behind Wi-Fi. So you ran into a lot of just legacy issues caused by that, and Wi-Fi 6 was designed to solve them. Those changes that they made to Wi-Fi 6 allow for higher capacity, basically allowing more clients to connect to the same AP without running into the connectivity issues you run into with 11AC. It was also a technology that's applied to both the 2.4 and the 5 gigahertz radio. A lot of people didn't realize that with 11AC only upgraded the 5 gigahertz radio and left the 2.4 radio operating at 11N. So with Wi-Fi 6, both radios can be now Wi-Fi 6. Some of our cheaper competitors out there still put a 11N 2.4 radio into their Wi-Fi 6 products. All of our Wi-Fi 6 products are Wi-Fi 6 across both radios. Doug is asking, do we have plans to come out with wireless bridges? So at this point, the answer to that is no. There are currently no plans for dedicated point-to-point products or wireless CPE type products. We are toying around with the idea of using Wi-Fi 6 outdoors to provide some sort of either CPE or point-to-point links, but that's in the very early discussion stages. So nothing in the near future as far as outdoor point-to-point goes. So one of the big differences here for Wi-Fi 6 is the performance when you have a lot of client devices connected to the same access point. So this orange line here is aggregated throughput. And as we travel right, it shows the aggregated throughput with more and more client devices connected. And one of the things you notice with 11AC products is as you add more users, overall performance degrades. So the aggregated throughput drops. When you're dealing with Wi-Fi 6 clients on a Wi-Fi 6 access point, the aggregated throughput is essentially flat, no matter how many client devices are connected to it. And that has to do with some of those technology changes in Wi-Fi 6 that are designed specifically to solve these issues that have been plaguing Wi-Fi for a while. So now we'll start talking about the different products that we have here. I will talk about Wi-Fi 6E in a little bit, and I will talk about Wi-Fi 7 here at the end. So talking about our products here. So we're breaking them up into 3 different categories here: simplicity, flexibility, and ultimate. The simplicity series are going to be our access points that are primarily aimed at that sort of SOHO space. So these are going to be access points that start with the letters NWA and then have 2 numbers after that. So our 50 and 90 series access points. The flexible series here are going to be our lower end true business class APs. So again, these will be NWA series access points, but they will have 3 digits in the model name or 4. So NWA 210AX, NWA 1123 ACV3. And then our Ultimate Series products here, those are going to be our true high-end business class products. The Ultimate Series is where you're usually going to find our dual optimized and smart antenna products. So we'll start here with our Soho type products. The NWA 50AX and not listed here, the NWA 50AX Pro are basically Amazon exclusive products designed to compete with the cheaper TP-Link and some of the Netgear products here. So they're AX 1800. They can be managed with Nebula using Nebula Flex. The NWA 55AXE we talked about earlier, that's our outdoor, low-end outdoor AP that is available through distribution. It's essentially an NWA 50AX in a dedicated outdoor enclosure. And then we have our 90 series access points. So they're basically the same as the 50 as far as the hardware specs go, but they unlock some additional software features for you. And I'll talk about those in a little bit. One thing I did want to talk about here is the Pro series, because there is some confusion to this. So generally when we talk about Pro, we were referencing Nebula and the optional Pro Pack license. So some people have seen NWA 90AX Pro and assume that that means Nebula Pro is bundled with them. It is not. The Pro is referring to some hardware differences between the 90 and 90 Pro or the 50 and 50 Pro. And when you go up to the Pro, there's two main changes. The first change is you have a 2.5 gig uplink port instead of the 1 gig uplink port on the non-Pro versions. And the second change here is these APs, the Pros support 160 megahertz channels, whereas the regular versions only support 80 megahertz channels. And what that does is that allows us to essentially almost double the speed from an AX 1800 class product to an AX 3000 class product, even though both of these only support 2 spatial streams. So basically you almost double the speed of those spatial streams by using double the available airtime for them. The trade-off of that, though, is a lot of client devices don't support 160 megahertz channels. And when you use 160 megahertz channels, there's only 2 non-overlapping 160 megahertz channels. So as soon as you have 3 APs trying to use 160 megahertz channels in the same area, you are going to have co-channel interference issues. So in general, it's not a technology I recommend in an office or business deployment. It's more of something you generally would use in a home type environment where you've got a single house and you don't have a lot of interference issues with it. Now, jumping up from here to our flexibility series here. So again, NWA products with at least 3 digits in there. I won't talk about the 11AC products we still have. Well, let's focus on 6 and 6E. We have the 110, the 210, and the 220. So the 110 is our entry level. It supports 2 spatial streams on both radios and gives us an AX 1800 speed. The NWA 210AX upgrades the WAN port from 1 gig to 2.5 gig. It gives us a 1 gig pass-through port, so you can run Ethernet out of the access point to another device. And it doubles the speed of the 5 gigahertz radio. So this becomes an AX 3000 product, but it gets there not by doubling the channel width, but by doubling the number of spatial streams. So this supports 4 spatial streams versus 2 on that 5 gigahertz radio, which is the better way to do faster speeds in a business type environment where you've got a lot of access points. And then the 220AX is our 6E product. It is only dual radio. So one radio is used for 2.4, and the other radio can be used for either 5 gigahertz or 6 gigahertz coverage, but not both at the same time. So we have a lot of people buying these, for instance, to add 6 gigahertz coverage in certain areas to an existing network, or buying these just for future-proof their networks, deploying it today with 5 gigahertz, and once 6 gigahertz support gets more widespread, switching it over to 6 gigahertz coverage. So there's probably a little confusion here when looking at these, right? Because we had the NWA 50AX, it's an AX 1800 speed product. We have the NWA 90AX, which is also an AX 1800 product, and the NWA 110AX, also an AX 1800 product. And then soon here we'll talk about the WAX 510D, which is also an AX 1800 speed product. So we get a lot of people saying, well, how do I know which of these to choose? They all have basically the same Wi-Fi performance. So I've put this little slide here together to sort of summarize the differences between the different series. So the main differences between the 50 and the 90 series, both of these are, I'm going to call them Wi-Fi 6 Lite. They don't support all of the Wi-Fi 6 features that are supported on our other higher end Wi-Fi 6 access points. So I call these Wi-Fi 6 Lite. Officially, they're still called Wi-Fi 6. Our competitors do the same thing. They don't highlight the fact that some of the features are missing. So unfortunately, we're stuck doing the same. So a little bit less on the Wi-Fi 6 support. And then the differences between the 50 series and the 90 series is the 50 series support, or excuse me, the 50 series lacks support for MAC authentication, radius authentication, captive portal, and layer 2 isolation. So that makes the 90 series probably a little bit more something you'd be more interested in using in a business network versus the 50 series, since the 90 series can do 802.1x authentication, it can do WPA enterprise, it can do captive portal for guest networks, and it can do layer 2 isolation. Going up from there to our true business class access points, we go from a 2-year warranty to a lifetime warranty. So NWA 110 and higher, everything is going to be lifetime warranty. This is full Wi-Fi 6, so it's got the full Wi-Fi 6 feature set included in them. And then it unlocks additional, what I would call business class features that you probably want. The ability to load balance between your access points, support for dynamic pre-shared key, the ability to use different NAT settings for different SSIDs on the access points. You can put different SSIDs on their own subnet. The ability to monitor your access points with SNMP. With Nebula Pro, the ability to support our artificial intelligence for auto optimization. Those are the features that you get on the 110 and 510 that you do not get on the 50 and the 90. And then the 510D, the WAC 510D, it adds dual optimized antennas and comes bundled with Nebula Flex Pro. So now we'll jump up to the Ultimate series here. So these are models that start with the letter W and then the technology. So if it's a Wi-Fi 6 access point, it's WAX. If it's an 11AC access point, it's WAC. And if it's a Wi-Fi 7 access point, it's WBE for the first few letters there for you. So these products, everything in the Ultimate series is going to come bundled with 1 year of Nebula Flex Pro. So Nebula is our free cloud management platform. Pro is an optional license which unlocks additional features for you, such as storing more logs in the cloud, storing a year's worth of logs in the cloud, having an audit log that you can look at, automatically generating a visual topology view, email alerts, things like that. So all of these access points come bundled with it. All of these access points can also be used with our local area controllers. So a lot of people didn't realize this, but our USG Flex and ATP series have a wireless LAN controller built in. So if you're deploying a large wireless network and you don't want to use the cloud, you can use our security gateways essentially as a access point controller for the W series access points. And then the differences between the three models are similar to what we just did on the previous slide for the NWA 110 and higher. The WAX 510D is an AX 1800 class product with 2 spatial stream support. Jumping up to the 610D adds the 2.5 gig port, it adds a 1 gig pass-through port, and doubles the 5 gigahertz performance by giving you 4 spatial streams. And then the WAX 620D is basically the 610D, but with support for the Wi-Fi 6E extended on the radio. And just like we were talking about before, it's a flexible choice. You either use 6 gigahertz or 5 gigahertz. You don't use both at the same time. Jumping up from there, we have our WAX 630S, our 640S, and 650S. And as the S at the end implies, these all have smart antenna technology built into them. Our WAX 630S is probably our most popular smart antenna access point. It is 4 spatial streams on the 5 gigahertz radio, 2 spatial streams on the 2.4. It is a 2.5 gig uplink port and a 1 gig pass-through port, and comes bundled with Nebula Flex Pro. The 640S is currently our only Wi-Fi 6E tri-band access point. So this supports 5 gigahertz, 2.4 gigahertz, and 6 gigahertz simultaneously. So if you want to offer Wi-Fi 6E and still offer 5 gigahertz and 2.4 gigahertz coverage, this is the model you want to look at here. And then our 650S has been our flagship access point for the longest period of time. It offers 4 spatial streams on both the 2.4 and 5 gigahertz radio, a 5 gig uplink port. It has a dedicated third radio, which is for monitoring DFS channels. So if you're using DFS channels on your access point, it reduces any downtime you may experience by allowing you to quickly switch from one DFS channel to another DFS channel without having to wait like you normally would if there is a legacy user nearby. It also has Bluetooth built in. So now we'll talk a little bit about Wi-Fi 6E just to explain it for you. And basically Wi-Fi 6E is just Wi-Fi 6, but it's been expanded to be able to use 6 gigahertz frequency. That was something that was opened up a couple years ago by the FCC for unlicensed use. So it's something you can use now. And basically it just gives us a lot more spectrum to play with and reduces interference because there's very few legacy 6 gigahertz devices out there. This little chart is showing you the bandwidth that's available in each different band here. So here's your 2.4 band, here's your 5 gigahertz band, here's 6 gigahertz. So as you can see, 6 gigahertz opens us up to a lot more RF spectrum than 2.4 and 5 gigahertz combined. That means you can have a lot more access points in the same area and not have to worry about interference between those different access points. As you can see here, when it comes to 160 megahertz channels, there's only 2 available in 5 gigahertz. That's why I was saying earlier, those pro APs, you probably aren't actually going to use those in a business environment at the full speed because you get interference issues really quick. Where with 6 gigahertz, you have 7 non-overlapping 160 megahertz channels. So it allows you to have 7 access points installed running at full 160 megahertz without interfering with each other. It's fantastic for business type deployments. So that makes it ideal for you here when it comes to high density environments and anything that requires a lot of bandwidth. Now, there are some trade-offs when it comes to 6 gigahertz support. One of those issues we run into here is the range is a lot less. Basically, as frequency goes up, range goes down as the signal gets absorbed much more quickly. So you will need more access points to cover the same area with 6 gigahertz as you need today to cover the area on 5 gigahertz. Another issue you run into is outdoor Wi-Fi 6 really isn't a thing. In order to use 6 gigahertz outdoors, you have to add a special subscription or third-party device that basically coordinates channel usage outdoors. So for today, for most of us, 6 gigahertz is purely an indoor solution. You can run into trouble with the FCC if you deploy 6 gigahertz outside. So just to cover here, we have 6E access points. We've already talked about all 3 of them. Main differences here for you guys is just these guys here are that band flex where you use it in either 5 gig or 6 gig, but not both at the same time. If you want to use all 3 bands at the same time, you want to go up to our 640S here. So now we'll talk about 7. So you probably saw this. We've had an email campaign. We've had a press release announcing our new Wi-Fi 7 access point. So let's talk a little bit about Wi-Fi 7 in general. So with Wi-Fi 6, we were advertising speeds up to about 10 gigabits per second. With Wi-Fi 7, they're advertising speeds theoretically up to 46 gigabits per second. They do this because they've increased the QAM, which is the way they encode data into the RF signal, so they can cram more data into the same space. Wi-Fi 6 uses 1024-bit QAM. Wi-Fi 7 upgrades that to 4000 QAM. We've now doubled the bandwidth utilization again. So where with Wi-Fi 6 and 6E, maximum bandwidth a single device can use is 160 megahertz. Wi-Fi 7 doubles that to 320 megahertz. And now we've get to some really new technology that we've got, which is called MLO, multi-link operation. It's the idea that a client device is able to connect on multiple bands simultaneously. So in theory, a client device could connect to your tri-band access point on all 3 bands at the same time. And then it can aggregate the bandwidth across all 3 of these to increase the overall bandwidth. Or alternately, you send the same data over 2 or more of your links. So that way, if there's an interference issue, which causes packets to be dropped and need to be rebroadcast, you don't have to do that, because hopefully if your 5 gigahertz radio drops some packets, those same packets also came through on the 6 gigahertz radio. So that as far as the application is concerned, nothing was dropped. So that allows you to lower latency over Wi-Fi connections and solve some of those annoying latency issues you run into when using Wi-Fi. So that's something that's really pretty cool there. Another thing we have here is something called multi-AP coordination. The ability for APs to be able to talk to each other and coordinate with their clients on how they want to divvy up available bandwidth if they're using overlapping channels. In theory, it could also allow client devices to connect to multiple APs at the same time, similar to before with a multi-link operation. You could connect to multiple radios in the access point. You'd be able to connect to multiple radios in different access points to be able to, again, solve some of those issues with packet drops for better latency, or just to aggregate throughput for greater overall bandwidth. So that all sounds great, but Wi-Fi 7 is going to be a little confusing here for you. So this is Wi-Fi 7 down here. So draft 1.0 came out back in 2021. Anything you buy today off the shelf that calls itself Wi-Fi 7 is based off of the draft that came out back in Q2 2021. And that includes our new access point. The first official release of Wi-Fi 7 isn't currently scheduled until Q2 next year. And then on top of that, there's going to be another release expected in 2025. So this is going to be similar to with 11AC, how we had Wave 1 and Wave 2. With Wi-Fi 7, you've got Draft 1.0, Release 1, and then Release 2. So it remains to be seen the actual features and implementations that will end up in the final versions of the Wi-Fi 7. So we don't know for products that you buy today based on the draft, how many of those features will be able to be supported on the current hardware via software update, and which of those features may require different hardware. So that's something to keep in mind. Wi-Fi 7 is going to be having a lot of changes. So our access point that we have officially announced, we don't have stock yet. This is skewed up at distribution. So if you wanted to buy it, you can probably place an order with distribution today. Our initial stock this year is going to be extremely limited. So we won't be doing evals or NFRs on it this year, but we probably will starting early next year. So for today, you're going to have to buy it full price if you want one of these. We also, because of the limited stock, none of our distributors will be stocking these. You will need to ask for them to drop ship it for you. Some distributors, you'll ask for it, they'll just do it automatically. Some other distributors, based on your sales guy, you may have to harangue them and push them a little bit to get them to set it up to do the drop ship for you, unfortunately, but that's just because we don't have enough stock to stock all of our distributors. So we're keeping it in our Anaheim warehouse and doing drop shipping. But the new access point here for you, it's the WBE 660S. It is tri-radio. So it supports 2.4, 5, and 6 all at the same time. All three of the radios support 4 spatial streams, so all are 4x4 that are built in on there for you. Now, in order, because of the just that horsepower, there we go. My slide's not working. I'm sorry. There's an in between slide that's not this. There we go. There we go. Okay. So because this has a lot of horsepower built into it, it does require a 802.3 BE or BT, BT PoE power to boot this up for full performance. So you do need to buy a switch with PoE that supports that 60-watt power to fully power this up and run it. Or you can power this using a USB-C connector. It requires a 45-watt PD USB-C adapter. We don't sell those, but there's millions of them out there on Amazon and other places that you can source your own if you want to power it up that way. It has a 10 gig LAN port in it to be able to support the higher speed. So in theory, the wireless performance is up to 22 gigabits per second. And realistically, you'll see about half of that because a lot of that is the Wi-Fi protocol overhead. So you should, in theory, be able to see wireless performance on speed tests in the neighborhood of 10 gigabits per second throughput on it, provided it is connected to a 10 gigabit switch and the 10 gigabit WAN, and you have the full power going into it here for you. It's based on a Qualcomm quad-core CPU. We are working hand in hand with Qualcomm to be able to provide firmware updates for it and unlock additional features as we go on here. So now some things to talk about. We were talking about before multi-link operation. At the moment, we do not support multi-link operation. It is something that will be enabled later. Why don't we support it? Because there are no clients out there that support it yet. So we haven't had a chance to test our implementation, verify it works. So as soon as some more clients come on the market that support MLO, we will unlock that additional feature for you. So let's just talk about clients right now when it comes to Wi-Fi 7. Basically, the only Wi-Fi 7 client device that's out there today is the Google 8 series. So the Google 8 phones support Wi-Fi 7. iPhones just launched the 15, and that's the first model that supports 6E. It does not support Wi-Fi 7. And at the moment, I don't think there's any laptops that support Wi-Fi 7, but they should be coming soon. Intel has a Wi-Fi chipset that's coming out, and I think you should start seeing products hitting the market in November or December this year that have the Wi-Fi 7 built in. But in order for you to support multi-link operation, those Wi-Fi 7 clients need to support it, and a lot of the first generation ones will not support multi-link operation. Why? Because it requires 2 separate radios in there, which requires more power draw. It requires a more powerful chipset to handle the throughput and the coordination. So for those reasons, a lot of your first initial Wi-Fi 7 devices are not going to support multi-link operation. Features like we were talking about before, that multi-AP coordination, I fully don't expect to see that until 2025 with that release 2 of Wi-Fi 7. And when it comes to multi-link operation, there's several different, ways of implementing it. So it remains to be seen what's going to be seen out there. So in general, what I'm going to tell you is buy our Wi-Fi 7 access point if you want to play around with it and be having the latest and greatest. In general, though, we're just now starting to see more widespread 6E support, and 6E's been out there for what, a year and a half, 2 years. So it's going to be a while before you see a lot of Wi-Fi 7 clients that can take advantage of our Wi-Fi 7 access point. And a lot of those early clients are going to be underpowered and missing support for a number of the Wi-Fi 7 features, just because of how much drain it would put on the battery as well as the extra cost. So you don't need Wi-Fi 7 today, but if you do want it to play around with, this is launching. We should have stock available in the next week or two to order through distribution, with better stock availability early next year. So it's there if you want it or if your customers are asking for it, but realistically, it's going to be a while before you see a lot of client devices that support the full Wi-Fi 7 feature set. And again, a number of those features probably aren't going to be out until the actual, Wi-Fi 7 release 1 or release 2 versions come out. So that is it for our presentation today. Go ahead and type in any questions you have, and I'll do my best here to answer them for you. Just to highlight here, most of our webinars are recorded. So you can find the recordings on our YouTube channel, Zyxel America channel. You can also find some video case studies, some best practices videos, etc. there. If you want to connect to us on LinkedIn, we are Zyxel US channel. And then we do have user forums available for you. It's forum.zyxel.com where you can reach out and talk to your fellow Zyxel users and installers. Those web forums are monitored by our R&D and support teams. They will often answer questions there. It's also one of the first places where we post security announcements, release notes, things like that. So it's a great thing to check out from time to time. Again, it's forum.zyxel.com. And I am not seeing any questions coming in. I'll stick around here for just a little bit. But I do thank you for coming out today. We do webinars usually on Tuesdays and Thursdays. As sort of a general rule, the more technical oriented webinars are done on Tuesdays and the more general salesy oriented webinars are done on Thursdays. And again, most of them are recorded. So if you can't attend, you can always find them on our YouTube page, usually within a day or two of the actual webinar date. And since there's no questions, I'm going to go ahead and end today's webinar. Thank you for joining us. I hope to see you at one of our future webinars.